Why is it so hard to go back to the moon? In the 60s and 70s, we went to the moon time and time again. But now it's 2026, we have supercomputers, we have AI, yet we can't stop a fuel leak. NASA just pushed back their first crewed lunar mission in 54 years back to March. So why does it seem so hard to go to the moon again? Hey Space Cats, I'm Dr. Maggie Lou, and in this week's video, let's look at why NASA is still fighting the same ghosts that have haunted the space shuttle missions. To date, there have been 6 successful human moon landings, all part of NASA's Apollo program, making that 12 people to have ever walked on the moon. The last one to do it was in 1972, so Apollo 17. It's now been 56 years, only 4 of those 12 are still alive. I have never witnessed a manned lunar mission, and it's really sad to think that there may be a time where no humans alive have stepped on the moon. Now, I was really looking forward to the Artemis 2 launch. Artemis 2 is the second of 6 missions with the aim to bring humans back to the moon, but this time to stay. But we've been to the moon countless times. So today I want to talk about why is it so difficult for us to do it again. Artemis 2 has been delayed due to a hydrogen leak. Now, this is disappointing, but safety first. And what is a few days in the grander scheme of things? Anyway, they set it up for this wet dress rehearsal, which is essentially when they practice the launch with everything except the astronauts inside and the actual ignition. They even fill the liquid cryogenic fuel, hence the name wet dress rehearsal. So actually, as soon as engineers transitioned from the slow filling to fast filling, before even countdown began, there were signs of a hydrogen leak. But still, they persevered and they were able to run the wet dress rehearsal down to T-5 minutes. Now, to be honest, to everyone, this was not a surprise. Rocket science is hard. SLS, the rocket that they use, uses liquid hydrogen propellant, which has the best efficiency or specific impulse, which is basically the miles per gallon for rockets. But hydrogen molecules are also the smallest molecules in the universe besides the noble gases, so helium or neon, because those ones don't really form bonds and exist as single atoms. This means that these tiny hydrogen molecules can often leak through seals that usually are able to contain other propellants like methane, kerosene, or oxygen. Now, if you think back to the Shuttle Challenger disaster, this was caused by cold temperatures making rubber seals in the solid rocket boosters brittle and inflexible, and this prevented them from sealing off a joint correctly during liftoff. The wet dress rehearsal was pushed back several times due to cold weather in Florida. And the only reason that they were able to push through and get down to those T-5 minutes was because the engineers working on SLS used a warming trick. They stopped the flow of hydrogen to let the seals warm up slightly, letting those seals re-expand and reseal. Unfortunately, this wasn't able to get rid of the problem altogether. But this has been a persistent problem, not only with the shuttle program, but also it happened with Artemis 1, the uncrewed mission to the moon that we had in 2023. This also had similar leakages. It's really disappointing that they weren't able to fix this in the last 3 years, but that's just the biggest downside of using hydrogen fuel. It's very difficult to stop all leaks. Now, the Apollo missions used Saturn V rockets. These used kerosene fuel, as do Soyuz and SpaceX's Falcon 9. These don't need cryogenic cooling like hydrogen does. They're very stable at room temperature, but it's less efficient than hydrogen, and it's also dirty. Its main byproduct is soot. Obviously, sustainability is much more important now than back then, and liquid hydrogen only creates water vapor as a byproduct. However, SLS also uses solid rocket boosters, which have non-environmentally friendly byproducts like hydrochloric acid and aluminum oxide. These are notorious for acid rain and ozone depletion. So a much better alternative surely should be liquid methane, which is already being used by SpaceX's Starship and ULA's Vulcan. Liquid methane propellant only produces CO2 as a byproduct, so it's cleaner. But unfortunately, however, policy and funding means that this was never an option for SLS. You see, SLS is kind of like this Frankenstein of a rocket. It uses a lot of old technology from way back, from the shuttle era. There's just no time or no money for NASA to redesign and test a brand new engine from scratch. And there's also this skills gap that was created when the Apollo era ended. The engineers who knew the tricks of the Saturn V rocket retired. And we didn't keep making those rockets. So the specialized manufacturing lines and all the knowledge behind it just vanished. But these are not the only things that are holding back the progress to getting humans on the moon again. NASA's risk tolerance in the 1960s was significantly higher. They were in a literal race with the Soviet Union, and the machinery was also a lot less complex. They didn't have all these sensors that triggered every single anomaly and just held up missions. People just went.
Sheldon, it's fine.
If it were fine, the light wouldn't be on.
Right now, NASA is dealing with the reality that they have not launched an SLS rocket in over 3 years. The seals on those launch pads have settled. The hardware have aged, and the teams are trying to relearn the feel of this rocket. It turns out that space is hard. It literally is rocket science. Anyway, that's all I have time for this week. Thank you to my YouTube Perks members for supporting this video. If you enjoyed it, please don't forget to leave me a like, share, and subscribe.
Hey, space.